Okay. Ah. So close. Okay, so we're working with, thank you, good morning. So we've been working with roots. Hopefully you guys had a chance to catch up on your study plan yesterday, or whatever it is that you want to work on so you can retake a test. 8.2, we're talking about rational exponents. Rational exponents. And all that's saying is that when you have a power, that exponent at the top is going to be a fraction. So it's rational exponents. So we're going to use exponential notation for nth roots. We're going to define and use the expression in the form of a to the m over n. Convert between radicals and rational exponents, and use the rules for exponents with rational exponents. So it's another laid back lesson. Probably, I know some people were able to do the first one without even listening to the lecture. So let's talk about using exponential notation for nth roots. Exponential notation for nth roots. Here we go. So if you have the nth root of a, and you want to express it in the form of a rational exponent, all you're going to do is take 1 and divide it by the index. So if we have the square root, that would be 1 over 2. If it was the third root, it'd be 1 over 3, so forth, so forth, so forth. Okay? Questions there? Okay. So in this case, if we want to evaluate this rational exponent, or this power with a rational exponent, then we can kind of just convert the other direction, right?
Can you go back, please?
Oh, yes, ma'am. There you go.
So, how was your morning?
That was all right.
You seem like you're in a bad mood. Yeah.
No, I'm sorry. I'm just tired. I'm like, this cold is really just like weighing down. My body is. Huh?
Now it's cold.
No, this cold. Like, I have a cold.
Oh, okay. We're like, you were saying it was cold the first day.
Yeah. No, if I didn't have a cold, I'd be like trying to feel that temperature outside cold.
It's 37 degrees.
I know, isn't that
Can't feel
cool?
anything now.
Your fingers are all numb.
Yeah.
I can't even pick up a pencil. No. No, I have a cold. I think it's turning into like a cough and stuff. Usually always happens with me. Okay, so let's try to simplify this power with a rational exponent. Again, we can already see that that's going to be a radical with a root of 5, right? So we can do something like this. And of course, we could just say, what's the fifth root of 32? And that is 2. Questions there? You have your ID, Alberto?
Oh, actually I do.
Thank you.
I do.
All right, cool. In this case, we're taking the square root of 64, so we can write it as such. The fifth root of 32. So some number to the fifth power gives me 32. Cool. All right. Nice. Got even a plastic case and everything.
That's what I do.
That's how I roll.
Keep stuff looking.
So in this case, we have 64 to the 1/2. That's simply saying the square root of 64. And so some number squared is 64. That number is 8. So there's 8. How about this? The negative 81 to the 1/4. Is that going to be the non-real?
Yes.
Well, in this case, we have to think back to our rules of inclusion, right? Our power, when we use parentheses and stuff. Is that inside a set of parentheses? Is the negative 81 inside of parentheses? So that negative is not protected. Remember that stuff? So that means that it gets kicked out, or you can kind of cover it up and go ahead and do what you need to do. And then you're going to see that that is going to be 3, so then that negative comes with it. And it's a negative 3. What
The ghost.
Something attacked me. Questions on that one? The only way that this would have been a non-real is again if the parentheses were there and you had something like this going on. Okay? But it's not there, so it's not protected. The negative is not protected. So you have that. Ah, there it is. So how about this one? That's a non-real because that means the fourth root of a negative 81. This root happens to be even, so we know that that's not going to be what happened, right? Now if it was odd, it's probably doable, but in this case it's not, so not real. Okay, how about this one? Well,
Yeah, because it's odd.
right, in this case where it's going to be the third root of that, this is an odd number, so I can have that negative inside, right? Negative, negative with another negative, and that's going to be negative 4. Totally doable. Shot. Easy chapter, yeah.
Yeah, that's pretty good.
Finish off strong.
How much harder does it get? It always starts off easy.
Stop saying that.
Well, it's a lie.
You smiled, so it's true. So
So,
Okay.
anything Callie's saying a lie. It starts easy and
Okay, so this last one
yeah.
is, excuse me, we're taking the third root of 127. You can choose to break it up if you want. Well, that's how you're going to write it, but you can write it if you want as 2 radicals. There's the third root of 1 over the third root of 27, but obviously they both do have a root. What happened?
I wrote it ugly.
Okay, and so that's going to just be 1/3. Questions on any one of these? Okay. All right, now I'm not sure why we had to do this one because the rule is actually a little bit more defined. And I think this one's done just so that you can kind of get an intro to it, simple intro. But this is kind of what we really want to talk about, to be able to define expressions in the form of a to the m over n. Okay. Now, the way I would like for you to write that m over n is to write it as a to the power over root. Okay, and m over n is more appropriate, but when I say power over root, it helps a lot of people understand what I mean when I'm doing this. Okay, so that's the actual definition. When you go back and you look at the other ones, everything that was inside of the radical, what was its exponent?
What was the question again?
Oh, nice setup. In the last one, everything that was inside of the radical had an exponent of 1, right? So I kind of you could say that was the first power. So when I say power over root, and you'll see that in a minute here. So let's take a look at this here. Why'd you jump to all the way over there? All right, well anyways, in this case, we have 25 to the 3 halves, right? There's a couple things that you can do here. If you want to go straight to radical from here, that's going to be 25. Now remember, it's the power over the root. So this would be the third power and the square root. So that's really what you're looking at. Okay? Now what they're having us do is to separate into 2 different things. Okay, because it's going to be helpful sometimes. Sometimes it's more helpful to do the root first and then the power, or the power and the root. So in this case, if you take a look at this, using those exponent rules, wouldn't that just be 3 halves? 1/2 times 3 is 3 over 2. Okay, but it really helps us to see it this way. I'm going to take the square root of 25, right? And then I'm going to take that to the third power. The square root of 25 is just 5. So 5 to the third would give me 125. Okay?
Is that the easiest
It's gonna be how you want to do it. Sometimes I prefer just to go straight to the power root and then go from there. But it really is going to depend on you how you want to attack it. There's your 125. Okay, so you guys want to try this
We
one?
don't have to do the first step. Like the 25.
It's up to you.
Okay.
It's going to be up to you. Okay, I would want to make numbers smaller, right? So remember, it's power over root. So you want to do the root first, and then take the power of that. Your notebook is cold?
Jacob loves your
You have an idea with it?
After you find out what you said about editor.
Got it? Okay, so just here, don't stress too much about it. This is 2 over 3, right? So what is the third root, right? The third root of 27 is 3. And then take that and square it. And there you go.
Oh.
Great job, Jake.
Okay. Make the number smaller, and then worry about making it bigger. Yeah, it's just a power of root. You can separate the two if you want, and that's what they were telling you at the top. You want to separate those, take care of the root first, and then do the power. For me, that seems like more work. And whenever there's more work, there's more room for making mistakes. So I'll just keep it the way it is. I know what each one represents, and I'll do that. Okay. There you go. Here.
Wait, I was right.
You get it on now? Is it negative?
Wait. It's
It should be negative.
It is?
The solution is negative.
Oh, yes.
Oh. Oh.
I don't know how to multiply that so much.
64.
Yeah. Yeah. It's negative though. But it's negative. You good? Not good? Okay. With this one or all of them?
No, I just don't know what to do after, like, you do the, because, okay, you did the 25, 3 over 2.
Right.
And then you did like 2 examples. And I got
Did you not understand those examples?
Well, because I don't know how you got, 'cause-
Okay, so let me do this real quick for you, okay?
wait, so do you find, my question is, do you find the square root
I would do the root first,
and
yes.
then you just put the exponent and then you solve that?
Yeah, I would do that first. Here, so let me show you with this one, okay? So here, this negative is not protected, so I can cover it up. Don't even pay attention to it until the end. So, what is the square root of 16? 4, right? So now I got to go 4 to the third. That happens to be 64. Remove my hand, and I get a negative 64.
Oh, okay.
Okay.
Wait, what happens to the bottom?
To the bottom what? We did it already. It's this here. And so let me show you what was happening. Right, because this is a negative 16, and if I spread up that fraction, it's 1/2 to the third, right? Because remember how you did this? It's 1 times 3, 2 times 1, it's 3/2. So this is really, if you remember from the first block we did, that's just the square root of 16, isn't it? The square root of 16 happens to be negative 4, and then I'm going to cube that, which means, yeah. And this is why I don't like the parentheses.
It confuses me.
Because according to this, you have a set of parentheses, don't you? And what would you have done with? Oh, that would still have been negative anyway. I'll take that back. But you see what I'm saying? If that was an even number out there,
Oh yeah. Makes sense.
okay, you would have it would have ended up messing it up. That's what I'm trying to say.
So you kind of technically don't want us to use parentheses?
I would personally would say no.
Yeah, because I got messed up whenever I was trying to, and I was like, oh my god. So then I was like, did it? So I guess.
Like this. So
Wish I didn't have that sneaker.
I think you were reading into the future, Jacob. When you wrote down your first answer to the last one, you were looking to the future.
No, I just don't remember.
I'm telling you, because what's the answer to this one?
I had it written down as negative 64. I don't know why I said 64.
Because you were looking to the future.
I see it now.
That's scary, man. Nostra Jacob.
Okay.
Wow. Peered into the future, man. That's deep. Nostra Jacob. Allie, you already got this?
Need the sneakers.
I get most of them, so.
I was just asking.
Oh yeah, that makes sense.
Looking out for you. Looking out for numero uno. Okay, here we go. Good job. That's, isn't it? I mean, it's nice because you show all your steps, but if you understand what's happening, and that's what's important, is that you know what's going to happen, then it's going to be good. Okay? How about that?
I need medicine for my sneeze. Sneeze.
Like, oh, and by the way, you should.
My dad is so disgusting.
Is it?
He's such a disgusting person. I don't
Oh my god. He doesn't.
Stop.
What?
The love of Reagan.
It's not real.
What's not real? Oh. Oh.
You're taking the square root. See, in this case, you have parentheses. You're taking the square root of a negative 32. The 2 is an even number. Therefore, you can't take its root.
We were all like.
I don't like this.
I like it.
Like, I like this.
No, they're telling you that the square root of it. If you know how they do their method, they separate the two. So they're saying, when we got to trying to do this, the square root here.
No, I'm just saying the negative 32 went to a negative 36.
Yeah.
I see what, yeah, that is a mistake. I think they meant 36. Because 6 times 6 is 36. I'm pretty sure they meant. I'm going to make that correction right now.
Wait, but isn't that real?
What?
I thought it would be 2.
No, it's still the square root of a negative number. Why for you no let me? The server application source or, okay, whatever. Let's see if they catch it in the other class. Okay. Why is this here? Okay. If a to the negative m over n, if you have negative m, if your exponent is negative, your rational exponent is negative, then just follow that rule. Remember with the powers? If it's negative, then you take it to the denominator. And that should make your fraction positive. Okay, that's still legit move. Still a legit move. Vice versa is true. If the rational exponent is negative on the denominator, then bring the whole thing to the numerator. And you should be good to go.
Good?
Good to go. Good to go.
It's a free drinks. He doesn't want to get caught.
You remember when you used to have a to the negative 2? And you'd be like, oh, you have to make that 1 over a to the second?
Oh, it's just the same thing.
It's the same rule.
Oh, okay, so I was like,
All they're saying is if you have, let's say, negative 2/3,
versus?
then that would become 2/3 down here.
Oh, so you just like transfer it down.
Yeah, you're moving the whole power down to the other side. Does that help?
Yeah.
Okay.
Yes, that helps.
You guys gotta ask.
Don't change. We did ask.
Oh, well, I saw her face. I thought I'd explain it to her. I guess she asked me with her face, huh?
That's how we do it now.
Break that! That reminded me of my little nephew. When he was little, like, he wanted to know everything. He was like, ooh, wow, what that? Ooh, wow, what that? Oh, wow, what that? Little 3-year-old running around. Oh, what that? It's a shirt.
You wear it.
It's a button. You know, it's cute like the first 2-3 times, but then you like, after 20 questions, like, oh my god. It's air. It's everywhere. Breathe it in.
It's super crazy though.
Aiden's just like,
I mean, if Kate, I'd be napping. He'd be like,
get away.
Louise dancing techno.
I hate when they ask why.
Yeah, it's the same thing. It's like the first 2 times like cool, and then after that it's like. So here's an example, and they already did it for you too. So if you notice, you have 81 to the negative 3/4. We're going to take the entire power down to the denominator. That's going to make this rational exponent into a positive, and then just go about your business like you normally would. What is the 4th root of 81? 3. And then you're going to cube that 3, so you're going to get 27. So you're going to get ba 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 ba. You can skip those if you need if you're okay with that. But that's what's going on. It's going down. Window. That's a great song. I really do like that a lot. What was that like? Late 2000s?
I couldn't say.
That was it. That one. I used to play that loud. That one and Tell Me When to Go.
You know what?
I still turn that one up. Tell me when to go. Here's the next example. You've got negative 36 to the negative 3/2. You're going to want that power to become, you're going to want the exponent of that power to become positive. So again, you're shifting it to the denominator. And then again, you go about your business. The square root of 36 is 6. And then you're going to cube that 6. So 6 times 6 is 36. 16. Thank you, because I didn't know what that was going to be. Good looking out, Jacob. And there you go. I have to do some mental math there. That was open, man. That was open, man. Which dance were you at, Alberto? What dance were you at when you were dancing that? What was it, like 5th grade? 7th grade? Let me see.
I need proof. I need like text messages and him being like,
How are you doing it?
I need the
Nah, hell. I don't remember it.
He probably has it on his phone.
That's probably older than us.
No, that song? No, that wasn't like 2000,
You can get some.
2008 maybe,
So
2007?
we're in like 5th grade.
You guys are like 5th grade. I think I said that, like 5th grade maybe. Like 2007, 2008. Alright, how about this here? Oh, this is a nice one. So, notice that your base number here is a fraction. So if you want to make this a negative, if you have a negative, all you really need to do is take the reciprocal of the base,
Flip it.
the reciprocal of the base, and that's going to become a positive. And someone might say, you know, why is that? Well, anybody want me to explain that real quick? Yeah, just take up all the time you need. Here's what's happening. Let's see if I can fit it over here. Let's say you do have that 64, and I bring it to the bottom, right? That means you're going to have 64 over 25 to the 3/2, correct? But can you really divide by a fraction? No, so what's going to happen? You kind of do that flip, right? So when you flip this, you're going to multiply by 25 over 64, but that's still 3/2. I didn't change it, I did a reciprocal. So this does not change power when I do that. Okay, I just flipped it. Okay, the original sign change was when I went from here to there. Okay, I brought the whole power down to the denominator. But since I can't divide by fractions, when you multiply by the reciprocal, right, it turns it into the 25 over 24, which is what we're looking at right here. Okay, so just a quick trip for you,
You do that.
a faster way of doing it. Don't spend your time shifting the whole fraction. Just do the reciprocal of that fraction on that base, and you should be good on the exponent.
I didn't even realize what he was doing. Last time
Okay, we're good? Moving on up.
Oh.
Here we go. Oh, did you need some of it? Sorry.
No.
Okay. A to the m over n. If all indicated roots are real numbers, then you can do that as well.
God.
Okay. And like I said, you can do the root first, or you can do the exponent first. It's totally up to you. So just showing you two different ways that you can do that.
Aw.
Okay.
I don't want to.
Well, here, let me show it to you with some numbers in there, because it might make more sense to you, okay? So let's say I had a to that 3/2, okay? So remember how we split up the 3/2? I can break it up so that it's 1/2. That's not a half at all, is it? I can break it up so that it's 1/2 times 3, correct? Okay. So what they're saying there, excuse me, is that when I'm doing the fraction breakup, I can say, you know what, this is a to the 1/2. Ah man, why am I to the 1/2 times 3? Or I can say that's a to the 3 times 1/2. Don't they both result in the same fraction at the end? So that's what they're saying. So if this was the root, I can choose to do the square root first, or I can choose to do the square root last. And that's all that's saying. However you want to do it. Personally, I think it's easier to make the numbers get smaller before I make them bigger. But sometimes when I do make them smaller, that smaller number doesn't have a root. But if I multiply it by itself and make it bigger, then I could probably have a root for it. So you're going to want to try both of them sometimes. Okay?
Oh,
Okay. Put your sun shades on.
I'm good.
He's not listening anymore. I can try to imagine him just out there. Little Alberto just
I was getting it back in the day.
fizzing. Is that what it was? Fizzing, huh? Out there fizzing on the floor.
Fizzle.
You're fizzing.
Yes, fizzle.
Oh man, I've been in this too long. No? Getting hyphy? That's fifth grade right there. Alberto's getting hyphy on the dance floor.
I'm still busy.
Oh man.
No.
Yeah, you were fizzing, getting hyphy, and all that good stuff. Alright, we're good near this?
Yeah.
Alright. Was that the same slide?
No.
Okay. Radical form. Radical form. It's the same thing, you're just going backwards, and I already showed it to you. So if you have, let's say, remember I said you had the, let's make this weird, like 5/3, okay? So we're going from power form over to the radical form. All you have to do is say, this is the, which one's the root again? The 3, right? So this is the third root of a to the 5th. That's all that's saying. Is if you want to switch between the two forms, that's the way you do it. And what did I say was? Power over the root. That's all you got to do. Okay, and that's what that's saying over there. Rubber there. Also important, remember I said you can either root or power? You can also do this. You can say, oh, that is the third root of a, and then we're going to take that to the 5th power. So either one of those works. Okay, so I suggest you write both of them. So here's your, I don't even know vocabulary today. There's your math. There's your math. Top one is abstract, the bottom one is more concrete, I guess.
There's the thing today.
What? What test? Oh, I'm glad you didn't say
We
English.
have one at Florence.
Why?
Because you already speak English.
It doesn't matter.
It does.
It really does. My
You know
English
what?
teacher
No, I agree with you.
weird
We're
stuff.
not.
I was always very disappointed because I never did well in English. Until I got to college, when I learned to just make stuff up. That's the truth. Like English, like how was I struggling? Like you can lie all you want in English papers, and they're like, "This is great." Like you should have just told me to lie. I would have got A's from the beginning. You make stuff up, make up stories, just ah.
That's just like, yeah, no, English was like your test.
No, but you have to write papers all the time. Write a convincing argument. I'll lie about the facts. You didn't tell me to cite anything. Your nose will turn to chocolate. You keep doing this. Blah, 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 blah.
What do you think we do on the AP exam?
Beautiful, exactly. There you go.
I don't think I've ever said anything memorable about what I thought about the essay.
But see, if people would get that sooner, life would be so much easier in English. And it was tough for me. The only thing I always did get hit on was my punctuations and stuff and my spelling because I was horrible at that. I needed the dictionary. Yeah, but I can't spell the squat. I still don't know, like, I still have trouble with, like, been there, I've been there, I've been there. Like, there's B-E-E-N, then there's B-E-I-N-G, and then there's the good old B-E-A-N.
You're like that.
So I'd be like,
We're friends. Then what to
pick one. Yeah, but see, I don't know the rules. I remember that I was trying to start a story, and I'm like, so we begin, but I spelled it begging, B-E-G-G-I-N-G. And so there's an extra G in there. Who cares?
Yeah.
No, it's not the right one. It's not the right. You wasn't begging. You're starting a story here.
Well, you have to start the story with those begging.
Yeah, I was begging. What are you talking about? Cool. So let's convert between rational and radical form. What is this going to look like as a radical? Just look at it. the square root of 19. Is there any power involved here? Yeah, it's 1, but that's understood, right? Otherwise, we would have 0. Actually, 1 if the power was 0. Take that back. So, same idea. How about there? It's the 4th root of 11 cubed. It's the 4th root of 11 cubed, and that can take on 2 forms. That can be the 4th root of 11 cubed, or that can be the 4th root of 11 cubed. So whichever one you saw first is okay, as long as it's one of those 2 forms.
No, he didn't. That's true. He was paying attention. He looked at me. And Dad just started nodding.
Na. How about this? 14x to the 2/3. Ooh, this is a tricky one. This one's a little curveball there, so you gotta be careful. You don't want to be careful there.
Ew. Don't ever do that again. No.
I got this down. I got it locked.
Oh my god.
You know what I'm saying? I got locked down. All the way down. Ah, nice boots. You're just like the boot girl, aren't you?
Yeah.
Sick. Those are nice. I tried on some boots on Black Friday. Actually, it was Black Saturday. And I couldn't get my foot through there. Yeah, like where it curves. My foot would not slide through. I'm like, make some manly boots here.
Are you sure they just weren't too small?
No. I went all the way to the 10 size and it was like no, there was like they had laces and stuff. So I thought it was like gonna be okay. Oh no. Yeah. Brittany, what'd you get, girl?
Girl, I don't know.
What do you think it is?
I barely caught on to the last exam.
You got this one okay?
Well, actually, you kind of explained it.
Okay, so try to take the same idea here.
I don't know, like,
Here's the trick, okay?
would I do 14? Would I do...
Let me ask you this question real quick before you continue, okay? That 2/3 goes to the x, right? Does it also go to the 14? No. Fantastic. So, it's 14 times. Okay. What root is it?
Would you do the square root 2 on the outside? And
Is it square root? You're talking about radical symbol, right?
then, oh, yeah. That,
Okay. So what's my index?
2 outside and 3.
Okay, do you remember my rule? P over R. P over R. Power over root. So what root is it? 3. So my index is 3.
Oh, okay. And then the 2 right.
I could put the 2 here. Or, I'm going to use another color, okay? Or I can do this and put the 2 out here instead of it being there.
Oh,
Okay? Either one is okay. Okay. Moving on up. To the east side. Oh.
It's like happy about this.
I do. I like it. Those are great examples. They're amazing. It's not magic. What time any goes to? Duty pati duty pami.
Is that a minus that?
Yes, sir. That is a minus symbol. called a subtraction symbol.
So could it, then would it just be 3x? Like, would it?
It would stay a subtraction problem. All you're really doing is converting this, and then all of that. Okay. That's the difference between this one. See how this 14 was not included? Here it is included, isn't it?
What? Wait.
That's all right, I clicked too many times.
Oh, I got that. Wait,
Good, so there you go.
I literally got that.
You're like not talking
Because you're awesome.
Gave the class 53 problems or whatever.
53 problems. My December gave that to us like I wouldn't do it on
Guys,
Saturday.
you
That one.
ever gave us more than 20?
Myers gave her class 53 problems for homework.
Who?
Myers. Well, she did that with us.
That would make me unmotivated to
Well,
check.
Like,
I've learned that.
I honestly would not do it. And it's not like that's our only core class. Like,
I
you know what
understand.
I mean? And then they're always like, well, I'm preparing you for college. Well, college, it's spaced out. Like, we have time to do it. Like, we see you the
We
next
don't
day.
have the same class.
You guys have Myers also?
No.
Thank God.
I had her last
You have her
year.
last
You know what? Don't jinx me.
No, I had her first semester, and then I had you second semester, and I went in there and I was like, like this isn't gonna work. And you do. And they're like, okay.
I got excited because I heard you're like a really good teacher. I was like, maybe I'll actually understand math.
So, have I let you down?
You've been the best math teacher I've had.
It's like,
Yeah, no, it's like forever.
Aw. Now you're gonna make my head explode.
well, my freshman math teacher was a long-term sub, and I didn't learn anything.
Oh.
Like, it wasn't that because we long-term sub, we just didn't know what he was doing. So it's like,
You guys had enough of these examples? Or sure? Oh, actually, let's do this one, because this one has a negative up there. And then we'll move on. Yeah, Caliber?
Did you?
They're all so good! They're not good? No. Oh, terrible.
Ew.
Terrible. How can you be so negative? Darn you, you rational exponent. Be more positive.
No, I'm like,
Exactly what you said, right?
Or I'm like, you just stop being so negative.
Barely.
That was good. Mom, why are you a rational exponent?
Honestly,
I think I
I
did.
would probably do it too. It's pretty ridiculous.
At least she's rational.
Laugh.
It'd be unfortunate if she was an irrational exponent. And negative at that. You're so negative and irrational.
Actually, I think I have a We're not like math waves.
She said you're negative and irrelevant to my life.
No, I
Ouch.
said
She
she's
said-
negative and irrational. Irrational.
Probably not no.
You're right.
I was like, you're irrational.
How many people got that? Either one of those. Either one of those. Okay, that's enough, I think. This is like overkill.
Oh, I forgot the one.
Okay. I'll give you guys a little bit of time to copy these rules down.
Oh,
Okay, I'm on it.
we don't have enough time.
Well, these rules you should already know. This is from the powers chapter,
I
right?
already know it then.
This is the product of powers. Yeah, you should already know these. This is the product of powers. So if this was a squared and a to the third, that would become a to the 3 plus 2, which is a to the 5th, right?
I know.
If you have negatives, you bring it to the bottom. Division is a subtraction problem. So these rules you should already know. You should already know those. And all this is really saying or confirming
Wait, I
is
still
that
remember.
those rules work consistently throughout math.
I used to.
Yep, I'm on it.
Hey, no PDA.
Guys, please.
Can't handle it.
Tomorrow's hospital.
World needs to know.
It's not school appropriate.
The world needs
The world needs to know. The world may never know. What is that? Tootsie Pop. Oh, actually we do that and we have lots of good data. Yeah, for stats, I always assign the Tootsie Pop, and they gotta record the number of licks it takes. So I have a distribution of licks, and on average, how many licks it takes. It's always a fun activity. Because then you see people doing all these different things, they're like,
From the speed licks, is that you click it at a weird angle, it's almost like a sharp.
oh, on one side. Okay. Okay, okay, artichoke. Oh, I'm so mad they don't give cell phones away now.
What?
You know how usually with Moni, if you did to your contract, you get a free phone?
Yeah.
Now they make you buy them.
No, you can send it to your contacts to some places. They have to do them online and on the store.
And they'll give you a free phone?
What? Well, not like a, I don't know, cell phones. For what?
It depends on the brand. They're not gonna give you like a free iPhone.
I don't know.
I don't
last
well,
year
usually we
for-
got nice phones. We always got
Samsung's are usually
okay.
free.
Yeah, Samsung.
I'll have to look for that. Thank you for the heads up. Never thought about it.
Yeah, I know, because I was in Scranton. This like lady was like all upset because they told her in store, but they can't do it in store.
But you can do it online. Cause see, I try to do it online on their store. Same thing.
Who do you have?
Sprint.
Oh yeah, you can do it.
Is it good?
Sprint?
Yeah.
No.
Decent.
Nah.
For the price, it's decent.
Because we have Verizon.
No,
Yeah,
Verizon is
Verizon.
good.
Verizon's expensive.
It's more expensive, but it's.
Verizon
worth
doesn't
it.
give me unlimited data and it makes me mad. 'cause
See,
I
I've
use a lot
unlimited
of data.
everything for Sprint.
I have a friend that took his Verizon phone into Mexico, in Sonora, and he can still use his USA service. That's how.
Well, if you go to like Maine or something, you can't use United States towers. You get stuck on Canadian towers.
Well, I'm just
What?
talking like for
Really?
the data.
Because when I was in
Would you
Maine,
have to go
I
to
got stuck on
Canada?
Canadian towers.
Would you have to go to Canada and buy a phone?
So what does Maine use for their main cell phone provider?
I don't know because
They
I
use
was,
two-way
I couldn't
radios.
even open my phone.
They probably use Canada.
They use
They told me
CDs.
where to buy phones.
Breaker, breaker.
Like, I got the
They use like a
cell towers with the weird
They
names.
still send letters.
Okay, so here we go. This is how tough they get. You guys ready? It says write only positive exponents. Assume all variables represent positive real numbers. So, hey, what is this?
What is that?
Oh, no, we're good. If you have the same base, what are you supposed to do with the exponents?
Multiply.
No, you add them.
Oh.
So, a half plus a third. I'd have to get a common denominator, right, which is what, 6?
Yeah.
So, I'd have to go get my 6, so that's 3 6 plus 2 6. So 5 plus 2 makes, 3 plus 2 makes 5. So that ends up being 5 6. Okay?
So we don't have to do anything with it.
No, because these are power rules. It's a product of a power. Okay? It's kind of like I said earlier. If you had a to the third and a to the second, then that just becomes a to the fifth.
So we just leave it like that?
How about this here? Okay. Here's my tip to you, real quick, just really quickly. Which one has a higher power there? The denominator does, doesn't it? So I'm going to move this to the bottom instead, and that's going to become 7 to the negative 2/3. So I'm going to get 1 left on top. Now I can do the same thing as I did up there. So what is 4/3 minus 2/3? 2/3. So that's just 7 to the 2/3. And if you want to get fancy with it, with your other rules, then that becomes 1, the third root of 7 squared.
Is it good just on 1 and 7 2/3?
Well, you're going to have to look at the instructions and see what the question says, okay? Because sometimes they'll say put in radical form. If they say just all positive exponents, then you can stop here at the first one, and you'd be okay.
Oh, no. Subtracted.
Which one breaks the couple?
Match against Casagrande. There's only one. This is stupid.
Okay.
We have tournament, but match is at today's play.
An extra 50 questions on the test.
Like we say about tournaments and stuff, but the match.
Let me see what else we have. Okay, that is it. So we'll just go to the bell doing these?
Oh, wait, but yes, I have a question.
Yeah?
Go back to the one that
This one?
Yeah. How did you? I don't understand.
Okay, so Thank you for saying something. So here, they have the same base, right? They have the same base. So instead of me bringing this to the top and getting a negative fraction, I thought I'd bring this to the denominator. And if I do that, that's going to become negative 2/3, right? So now, if I've taken this from the top to the bottom, what's left in the numerator? Well, a 1. So I'm going to put the 1 there. So this kind of becomes a 1. Now, they have the same base. So if they have the same base, I can add. See that? I can just add. So 4/3 minus 2/3 leaves me with 2/3, doesn't it? So that's 7 to the 2/3. So if they said, in this case, only positive exponents, I'm done. Now, what I said is if you want to get fancy on paper, then I'm going to use my radical, remember thing, the rule?
Yeah.
It's 7, and I can write it as 7 squared, right? 7 squared, and what's the root of it? 3. Or you can write it the way I wrote it earlier, which was the 3rd root of 7, and then I square it. Okay, so either one of these both mean the same thing. Actually, all 3 of them mean the same thing. But it's just going to be a matter of...
Can you leave it like that? Like,
in this case, they said only positive exponents, so I would leave it like this.
okay.
Just like that one. Okay? Just dance. It's gonna be okay. Just dance.
Did you get your dog up? She goes, no.
I still haven't tried it.
Trident is good.
No, we didn't. Trident.
Trident gum?
I said try it.
Oh. My bad. That's what I get for doing the conversations I don't know anything about. That's what I get for getting to the Kool-Aid not knowing the flavor. What was that? The Kool-Aid also? I don't know. Oh, all of them in Kool-Aid don't even know the flavor.
Wait, what did you do? Did you just like quit? Were you just like, eh?
I need a bathroom. What? November 5th. And I told her in July.
Alrighty.
Figure out, so like October.